Hello again. In this video, we're going to talk about how we find the location of absolute maximums and absolute minimums. So before we actually go through the procedure of locating absolute maximums and minimums, let's talk about where they can occur. There's actually two places where they can occur. So let's say we have the graph of this function f of x, and it looks like this. I think you can see on this graph that the absolute minimum is 2, and it occurs when x equals 5. Notice x equals 5 is actually the right endpoint of the domain of this function. So I think you can see that absolute minimums and maximums can occur at the endpoints of the domain of your function. But they can also occur at critical points in the interior of the domain of the function, because here the absolute maximum, which is 7, is occurring at 3. And 3 is the location of a critical point, because the derivative at this point happens to be 0. Okay, maybe as another example, just to kind of reinforce this idea, if you look at the graph of g of x, the absolute minimum is 3, and it occurs when x equals 4, which happens to be a critical point, because the derivative at that point is undefined, or doesn't exist, because it's a sharp corner. So again, you can have an absolute minimum or maximum at a critical point in the interior of the domain of your function. But they can also occur at the endpoints, because the absolute maximum in this case is 8, and it occurs at this endpoint, the left endpoint, when x is equal to 2, right? The left endpoint of the domain. Okay, so just keep that in mind. So what we're going to do is we're going to go through an example where we find both the absolute maximum and minimum values for this function on the interval from -2 to 2. Okay, so the first thing we're going to do here is we're going to find the critical points, because we know that absolute maximums and minimums can occur at critical points in the interior of this domain. Okay, so let's find the critical points. Okay, so to do that, we have to find the derivative first. Of course, the derivative of this function will be 4x cubed minus 6x squared. And then we're going to set that equal to 0, and then find out when it doesn't exist. Remember, that's the definition of a critical point. Critical points have to be in the domain of the function, and they are locations where the derivative is 0 or doesn't exist. Let's talk about where this derivative doesn't exist. Well, this is a polynomial, right? This is a third-degree polynomial. So the derivative exists for all values of x. You can plug any number you want into x here, and you're going to get a number out. And so this never happens. Okay, but it could be equal to 0. So let's see for which x values is the derivative 0. Okay, so to solve this, you probably want to factor out an x squared and maybe a 2. So let's pull out 2x squared out. And that's going to leave you with a 2x here. And then here you're going to be left with a minus 3. Okay, and then you just set both of those to 0 and then solve for x. Here, you divide by 2, and then you take the square root of both sides, and you get x is equal to 0. This one, you just want to add 3 to both sides, and then divide by 2, and so you get x is equal to 3/2. Now, let's go back and make sure these are actually critical points. Notice that both of them are in the domain of this function, so they really are critical points. It is possible that maybe we got a not a critical number, but we got a number here like x equals 7. If that happened, then it would not be a critical point, because 7 is not in the domain of the function. But both of these are in the domain, so they're both critical points. Now, These are possible locations of absolute maximums and minimums. The other possible location of absolute maximums and minimums are the endpoints of the domain. So we also need to check -2 and +2. And so the last thing we're going to do here is we're simply going to make a t-chart where we check the endpoints, -2 and 2. And we find out what the y values are at the endpoints. And of course, we need to plug these into the original function to find the y values. Okay, so you're going to take -2 to the 4th power minus 2 times -2 cubed. Okay, so -2 to the 4th power is 16. -2 cubed is -8. So you get -2 times a -8, which is a +16. Okay, so the y value here is 32. And now let's plug a 2 in. So you get 2 to the 4th minus 2 times 2 cubed. And of course that's 16. And this one is also 16. 2 cubed is 8, and then 8 times 2 is 16. And so you get 0 for the y value here. Okay, now when you plug 0 in, of course you get 0 out. And then you have to plug 3/2 in. Now plugging 3/2 in, you get 3/2 to the 4th power minus 2 times 3/2 cubed. Okay, so when you raise this to the 4th power, you can just say 3 to the 4th, which is 81, divided by 2 to the 4th, which is 16. And then here you can just say 3 cubed, which is 27, over 2 cubed, which is 8. And then you're going to multiply that by a 2 and then subtract it. Okay, and of course you're going to need a common denominator here of 16. So I'm going to go ahead and force in the denominator of 16 by multiplying this by 2 over 2. And so you end up with 81 over 16 minus 54 times 2 is 108 over 16. Okay, and then 81 minus 108 is minus 27 over 16. Okay, now look, after you've done that, all you're going to do now is look at the y values that you have here. We know that the absolute maximums and absolute minimums must occur either at the endpoints or the critical points. And we found all of those and their corresponding y values. So now it's just a matter of finding out which one is the largest y value and which one is the smallest. Well, the largest y value is 32, so that is an absolute maximum. And then -27 over 16 is the absolute minimum. Now be careful. The absolute maximum is 32, and that occurs when x is -2. And then the absolute minimum is -27 over 16, and it happens to occur when x is equal to 3/2. Okay, just to reinforce this, let's look at the graph of this function. So if you graph this function, right, x to the 4th minus 2x cubed on the domain from -2 to 2, it looks like this. And I think you can see that maximum is 32, and that occurs at this left endpoint when x is -2. And then the minimum, absolute minimum, is right here, which is at -27 over 16, and that happens to occur at 3 when x is 3/2. Okay, and by the way, that's a critical point, whereas this is an endpoint. Okay, so I hope you found this video helpful. Thank you for watching.